Hi there. We're going to start off by going through Chapter 2 notes. This is for Chapter 2, Section 1, and this is Day 1. At the top of your notes, you're going to find a table, and all I want this table to do is to get you used to, remembering from last year, degrees, naming the degree, and just that you had an example come quiz time. So in the first column, you'll see degree, undefined, name using degree, zero function, and then we have an example. The first one that we have to fill in is right here where it has a degree of 2. Name using degree, so if you remember, anything with an x squared is called a quadratic. You'll have to excuse me using this pen. Example, it's anything with an x squared, literally anything. So I'm going to do f of x equals x squared plus 2x plus 1. You can change it if you want to. I just want you to have an example. The other one we have to fill in is, it states that it's a cubic. Here's an example of a cubic. So what's the highest degree? The highest degree is going to be the exponent of that term, and that's going to be 3. I'm going to erase just that part so I have room in the next portion. A leading coefficient, that is, yikes, leading number after a function is in standard form. Standard form goes from the highest exponent to the lowest exponent. The cubic function, that example is in standard form. It goes x to the third power, there's no x squared, then you have your x, and then just your constant. Examples of non-polynomials. No, first one is going to be no negative exponents. In your notes, I would recommend not shorthanding that. I'm shorthanding it because my handwriting ends up worse on this, which is shocking. Next, no fraction exponents. You can either write this out or you can actually put examples. Next one is division if you cannot simplify. I'm going to erase that just to get myself more room. Division if you cannot simplify. I'll show you exactly what I mean. We talked about this in the worksheet from a few days ago, but I will show you exactly what I mean. Another example, it's a big no-no, square root. Anything where you're taking the square root of a variable, that's a problem. It's not a polynomial. You can take the square root of a number because that ends up just being another number. The last no-no is variable exponents. So if you had 3 raised to the x power, that is not a polynomial. I'll give you a second to finish writing. I'll erase this and then we'll continue on. All right, moving on. Let's see if I know how to do this. There we go. Okay, determine if the following are polynomials. For those that are polynomials, state the degree and leading coefficient. If it is not a polynomial, state why. So let's look at the first one. We do have a fraction, but it's not a fraction exponent. If I look at the exponent, here I have a 3. 3's are okay. So let's put that in standard form, which means the highest exponents go first. We'll have 4x cubed minus 8x plus a half. Now that this is in standard form, it's just a little bit easier to look at the degree and leading coefficient. If you can determine the degree and leading coefficient without putting it in standard form, then you can skip this step. So our degree is going to be 3 because that's our highest exponent, and our leading coefficient is going to be 4 because it's the number out front of the degree. Number 2. Number 2 I have an issue with because we have a negative exponent. So no, this is not a polynomial, and it wants us to state why, so I had negative exponent. That's a problem. That's a no-no. It's not a polynomial. Number 3 is a problem. Why? Because we have variables here under a square root here. No, the issue, the square root. Moving on to number 4. Again, you don't have to put it in standard form. Out of habit, I'm going to go ahead and do that. That should be a 5. It's a little scary, but it should be a 5. We have a negative number out front. That's okay. As long as the exponent, which is a 4, isn't negative, we are fine. So yes, this is a polynomial. It has a degree of 4. Why? Because it's the highest exponent. And it has a leading coefficient of negative 2. Why? Because that's the number out front. Oh, we can do it different colors. All right, number 5. This one is already in standard form. Not that you have to move it over, but it's just already done for us. I just want you to remember some of those things from Algebra 2. This is a polynomial because it doesn't fall in any of the categories we already talked about. So yes, this is a polynomial. The degree is going to be the highest exponent, which is 5. And the leading coefficient is the number out front. Well, if there isn't a number out front, what number is always, always, always there? The number 1. Number 6. We do have some division here. So my question to you is this a polynomial or is it not a polynomial? With division, division is a problem if you cannot simplify. There's no way that I can get rid of that x in the denominator because there's nothing that I can cancel from the numerator. So this is not a polynomial. No. The reason why? Dividing by a variable, or in this case, I'm just going to put dividing by x. It's just easier. All right, let's move on to the second page. I'm going to erase all of this, and you can pause the video if I'm going too quickly and you need to copy this stuff down. It's always an option. All right, I need to change the background. Oh boy. That one. All right, I think I've got the hang of this. All right, rate of change. We talked about this last week. So our rate of change is the change in y. All right, I'm not sure why that's moving around. Now it works, great, okay. Change in y over the change in x. All that triangle means, it's delta, it's change. Our equation was f of b minus f of a, all divided by b minus a. Point slope form, that should also be familiar. Let's try the marker feature. That is y minus y1 equals your slope times x minus x1. Number 1 in the example says, write an equation for the linear function of f such that f of negative 2 equals 5, and when the function is at 3, the y value is negative 1. That's all that's saying. Graph to support your equation that goes through those 2 points mentioned. All right, well, let's figure out these 2 points. So when the function is at negative 2, our equation, or our other intersection point, is at 5. So that means your first point is negative 2, comma 5. The second point, when x is 3, y is negative 1. So we need the slope. To do that, we're going to plug it in for y2, which is here, minus y1. Use a different color for emphasis. Minus 5, x2 minus x1. Watch out for the negatives. Here I have negative 1 minus 5, which gives me negative 6. In the denominator, I have 5. So our slope is negative 6 over 5. Hate fractions? Turn it into a decimal. Next, we're going to pick a point. So I think I'm going to need more room, so I'm going to erase this. Remember that our slope is negative 6 over 5. You can pick either point. It doesn't matter. You're going to end up with the exact same equation. So I'm going to pick 3, negative 1. Why? Because I feel like it. Then we're going to plug this in for the point slope form. So you have y minus y1, which is here, equals our slope, and then x minus x1, which is there. That's going to turn into a positive, so I have y plus 1 equals, here we're going to do the distributive property. So I have negative 6/5 times x, which gives us negative 6/5 x. And then I have negative 6/5 times negative 3. Well, if you remember how fractions work, negative 6/5 times a negative 3, really that's 3 over 1. I'll just do the quick work over here. So if we multiply that out, that gets us positive 18 over 5. Continuing on, I need to subtract 1, minus 1. My equation is going to be, I don't know what that is. I'm not sure what happened. So we have y equals negative 6/5 x plus, so I'm subtracting off 1. Well, writing 1 as a fraction in this case would be minus subtracting 5 over 5 to give this the same denominator. And that's going to give us 13/5. So that's our equation, and it wants us to graph. So you can do a couple different things, but for me, I'm just going to graph these two original coordinate points because that's easiest. So I'm going to go back to up 5, and I'm going to put a point. And then I'm going to use my other point, which is 3, negative 1. There's my line. I hope yours looks better than that. All right, if you need time to copy, please pause the video. If not, we're going to erase and continue on to the last problem. Ideally, what I would like you to do is to pause the video and try the next problem because you have everything that you need. But if you're not comfortable, then we can do that together. Oh good, number 2 is cut off. So what we're going to do is do number 2 up here. Write an equation, my 2 points, I have 0, negative 2, and negative 3, positive 4. I'll get used to this. Our slope is going to be 4 minus a negative 2 over negative 3 minus 0. This is going to give us a positive 6 over negative 3, or a slope of negative 2. I should have said in the beginning, please don't write this large. I have to do this in stages. So if you need to copy that down, please pause the video. All right, remember that our slope is negative 2. Next, we're going to pick a point. Again, it doesn't matter which one. I'm going to use 0, negative 2. Why? Because it has a 0 in it, making my life a little bit easier. I'm going to plug in 0 minus y1, which is negative 2, equals slope, negative 2, x minus x1, which is 0. This turns into plus 2. Doing the distributive property, I'm going to have negative 2x. Negative 2 times negative 0 is just going to give us 0. So I'm not going to add on a plus 0 here. Subtract 2 when I get the equation, y equals negative 2x minus 2. To graph that, what this equation means this is an mx plus b. B is your y-intercept. So if my y-intercept is at -2, I'm going to go to the graph and put a dot at -2. This is my slope, m. If my slope is -2, I'm going to go down 2 units over 1